In the last session, we completed the orthogonal trajectories of the Cartesian form. Now we are going through the orthogonal trajectories of polar form. Polar form means that one having the coordinates as r comma theta. So whatever working rule we applied for Cartesian coordinates, same rule we are applying here also. First framing differential equation. Next replacing for orthogonal trajectories we are replacing derivative. In third step we are evaluating the general solution of the differential equation. So here, see this. First step, find the differential equation and is of the form f of r comma theta comma dr by d theta is equal to 0. In previous Cartesian coordinates, we replace dy by dx as minus dx by dy. But in this polar coordinates, replacing dr by d theta as minus r square d theta by dr. In third step, we are evaluating the general solution of this differential equation. Here also 3 steps required. What are those 3 steps? First, framing of differential equation by eliminating the arbitrary constant. In second step, for orthogonal trajectories, replace dr by d theta as minus r square d theta by dr. In third step, we are evaluating the general solution of the second step. What is the second step? This one. So for this, we are evaluating the general solution, and the general solution is of the form g of r comma theta comma a is equal to 0. So on this we are going through an example. Say this. Find the orthogonal trajectories of the family r theta is equal to a. R theta is equal to a. Given family is r theta is equal to a. Here independent variable is theta. Differentiate with respect to theta on both sides. Then u formula. U into derivative. So u into derivative of v. So r into theta derivative 1 plus theta into dr by d theta. This is equal to 0. That equation we will get. So in this, find the orthogonal trajectories of the family r theta is equal to a. R theta is equal to a. R theta is equal to a. So given family equation r theta is equal to a. Differentiate with respect to theta on both sides. So r into theta derivative is 1 plus theta into r derivative dr by d theta is equal to 0. So equation is r into theta into dr by d theta is equal to 0. So here this is our equation. So first step completed. In the second step, for orthogonal trajectories, replace dr by d theta as minus r square d theta by d. So this equation is r plus theta into minus r square d theta by dr is equal to 0. So take out common r minus r theta in take out common r, then this one is 1 minus r theta into dr by d theta by dr is equal to 0. So that implies r goes to that side, that becomes 0. 1 minus r theta into d theta by dr is equal to 0. That implies 1 is equal r theta into d theta by dr. Bring r and dr into the left hand side. 1 by r into dr is equal to 1 by theta into d. Now make integration. So integrate on both sides. Integral 1 by r dr is equal to integral 1 by theta d theta. 1 by r integration log r, 1 by theta integration log theta, constant also same. So log r is equal to log c theta. Log a plus log b is log ab. So r is equal to c theta. This is the required orthogonal trajectories of the given family. So like this we are calculating the orthogonal trajectories of the family. So next problem is, say this. Find the orthogonal trajectories of the family r power n into cos n theta is equal a power n. So given family is r power n into cos n theta is equal a power n. So this here it is a product term. So first I will if there is any powers or product, if you are applying logarithm, then our problem becomes very easy for evaluation of the differential equation. So apply log on both sides. Log of r power n into cos n theta is equal log of a power n. So log a b can be written as log a plus log b. So log a b can be written as log a plus log. So log r power n log of cos n theta is equal log of a power n. So log r power n log a power b can be written as b log a. Log a power b can be written as b log a. Log r power n can be written as n log r plus log of cos n theta is equal log a power b can be written as b log a. Differentiate with respect to theta on both sides. We will get n into log r. Log r derivative. So log x derivative. What is the derivative of log x? Log x is equal 1. So log r derivative 1 by r. Again r derivative dr by d theta. Log of cos n theta derivative 1 by cos n theta. Again cos derivative minus sin n theta into again n theta derivative is n. So n is equal to 0. For orthogonal trajectories, replace dr by d theta as minus r square into d theta by dr. So n into 1 by r minus 1 by r into dr by d theta is minus r square d theta by dr. 1 by cos n theta into minus sin n theta into n. Because of that, sorry. Here, actually you will get n here. So this, here log of cos n theta, right. So here I will get n. So here also I will get n. This one n and this one n. So this n into 1 by r minus r square d theta by dr into 1 by cos n theta minus sin n theta into n is equal 0. So r getting cancelled, minus n r d theta by dr minus n into sin by cos can be written as tan n theta. So minus n r d theta by dr is equal, minus n comes to this side plus n getting cancelled. So here we will not get n. So minus into, bring this tan into the left hand side, 1 by tan n theta d theta, r goes to right hand side, 1 by r dr. So integrate on both sides with respect to theta, then we will get, so there is no n here, minus integral cot n theta d theta is equal 1 by r dr. So here this n will not comes, this n goes to this side, n log c. So integral cot integration is what? Log mod sin n theta. Again n theta derivative is n we are writing in denominator. Because of that, integral f of ax can be written as f dash ax by again ax derivative is a. Like this, cot derivative log mod sin n theta, again n theta derivative is n is equal 1 by r integration is log r plus constant derivative. Both are logarithms, in that's why constant also I take as log c. So log of sin n theta is equal log a plus log b is log ab. This n comes to this side. So log of sin n theta is equal b log a can be written as log a power b. Logarithm getting cancelled. Sin n theta is equal r power n. Again c power n is c. So r power n into c is equal sin n theta, which is required orthogonal trajectories of the given family. So what we done here, first we evaluated the differential equation. In second step, for orthogonal trajectories, we replace dr by d theta as minus r square d theta by dr. In third step, we evaluated the general solution by using known methods. So like this, we are evaluating the orthogonal trajectories of the family. Now here, I am going through the one more problem. This is the last problem related to the polar form. So see this, find the orthogonal trajectories of the family r is equal a into 1 plus cos 2 theta. So first, given family is r is equal a into 1 plus cos 2 theta. Here a is an arbitrary parameter. For our convenient purpose, I am writing this one as r is equal a into cos 2 theta. What is the formula of cos 2 theta? 2 cos square theta minus 1. From this, 2 cos square theta value is 1 plus cos 2 theta. Then this one, a into 1 plus cos 2 theta value is 2 cos square theta. So r is equal to 2a cos square theta. For our easy convenience, apply log on both sides. Then this one, log r is equal log 2a into cos square theta. So log r is equal log 2a plus log of cos square. Like this also, like this we will differentiate. After we are applying derivative with respect to theta for this equation, then also we will get the orthogonal trajectories. But I will do this problem as it is. So what is the problem? R is equal to a into 1 plus cos. So here differentiate with respect to theta. R derivative is dr by dt. A into 1 derivative 0 plus cos derivative minus sin 2 theta. Again 2 theta derivative is 2. So dr by d theta is equal minus 2a into sin 2 theta. Okay, a does not eliminate it. From this, calculate the value of a. A is equal minus 1 by 2 sin theta into dr by theta. Substitute this value in that equation. What is the equation? R is equal a into 1 plus cos theta. So like this also we have to do, but I am not doing like this. I am making directly differentiation. So from r is equal a into 1 plus cos 2 theta. Substitute the value of a in this. R is equal minus 1 by 2 sin 2 theta into 1 plus cos 2. R is equal minus 1 by 2 into sin 2 theta can be written as 2 sin theta cos theta. 1 plus cos 2 theta value 2 cos theta. 2 getting cancelled. Cos theta getting cancelled. What is remaining? Cos. Cos by sin is cos. So minus 1 by 2 cot theta. So R is equal minus 1 by 2 cot theta. Dr by small r is equal. Where is dr by d theta? Into dr by d theta. So for orthogonal trajectories, replace dr by d theta as minus r square d theta by d. So r is equal minus 1 by 2 cot theta minus r square d theta by d. R are getting cancelled, minus into minus plus, 2 comes to this side, 2 is equal cot theta into r into d theta by d. So bring this r into the left hand side, 1 by r dr is equal cot theta d. Integrate on both sides, 2 into 1 by r integration dr log r, cot theta integration log mod sin theta, constant integration log c. So log r square is equal log c sin theta. That implies r square is equal c sin theta, which is the required orthogonal trajectories of the given family. So with this I will complete and completing this session. So in the next session I will say about the self-orthogonal trajectories after the second application, which is called Unit2 Lecture8. Thank you. Good morning students, welcome to this session. In the last session we completed about the orthogonal trajectories in Cartesian form and polar form. Now in this session we will learn about the another application and one of the topic in orthogonal trajectories. The topic is self-orthogonal. Which term is which family is said to be self-orthogonal family? So here two family of curves are said to be self-orthogonal if the differential equations are same. It means two families. For example, pi is one set of family, xi is another set of family. The differential equation of this one and the differential equation of this one are same, then these two families are said to be self-orthogonal. What are these differential equations? Given family. How we will calculate orthogonal trajectories? First we are framing differential equation. So that one is of the form x comma y comma dy by dx is equal 0. Next we are replacing dy by dx as minus dx by dy. So this one is x comma y comma minus dx by dy is equal to 0. Next we are solving this one. We will get a family z. That means, so this two family of curves are said to be self-orthogonal. So here this is family, this is another family. So the differential equation of this family is this one. The differential equation of this one is this one. If these two are same, then this family is said to be self-orthogonal to this family, and this is orthogonal to this family. Like this we are saying that. That means which is nothing but we have to evaluate the differential equation of the given family. After that we are evaluating orthogonal trajectories differential equation. If these two are same, that means there is no need to evaluate solution of second differential equation. If these two differential equations are same, then this is said to be a self-orthogonal. Now here we are going through one of the problem. So this show that the family y square is equal to 4a into x plus a. The family y square is equal 4a into x plus a is self-orthogonal. So for this given family equation, given family is y square is equal 4a into x plus a. Y square is equal 4a into x plus a. Here a is an arbitrary parameter. Our aim is to eliminate that arbitrary parameter from the equation. For this, differentiate with respect to x. Y square derivative is 2y into dy by dx is equal 4a is the coefficient, x derivative 1. So 2y into dy by dx is equal 4a. Here a does not eliminate it. So use this and this. We are eliminating the value of a. From this, what is the value of a? 2 times getting cancelled. A is equal y by 2 into dy by dx. Now we are using equations 1 and 2. We are eliminating the value of a. So use 1 and 2. So from 1 implies y square is equal 4 into a value is y by 2 into. See this. Here every time writing dy by dx becomes difficult. In that's why I will rewrite that one as y. So y square is equal 4 into y dash by 2 into x plus y dash by 2. That implies y square is equal 2 into y dash into, take LCM. What is LCM? 2. 2x plus y dash. So here 2 getting cancelled. What is remaining? In the next slide I will write y square is equal y dash into 2x plus y dash into 2x plus y dash. 2x plus y dash. Now multiply inside. Y square is equal 2x y dash plus y dash whole square. So this is the required differential equation of the given family, and here there is no arbitrary parameter. Let it be 3. After this, for orthogonal trajectories, replace. What is the formula? Actually formula is dy by dx as minus dx by dx. Dy by dx denoted as y dash, as minus 1 by dx comes to denominator dy by dx, that becomes as minus 1 by y dash. So replace y dash as minus 1 by y dash. Then 3 implies y square is equal 2xy into minus 1 by y dash plus y dash whole square, y into minus 1 by y dash whole square. That implies y square is equal minus 2xy by y dash plus y square by minus 1 whole square plus y dash whole square. Take LCM. Y square is equal, LCM is y dash whole square. Y dash times getting cancelled. Y dash into minus 2xy minus 2xy y dash plus y dash whole square one time getting cancelled. 1 into y square. Now cross multiply this one. Y square into y dash square is equal minus 2xy y dash plus y square plus y square. From this I want y square. Bring this one into the left hand side. Y square is equal, minus term goes to left hand side, 2xy y dash plus y square y dash whole square can be written as y into y dash whole square. Let it be 4. Observe equations 3 and 4. Both are same. This is our equation number 3 and this is our equation number 4. If you are observing those two are same. That means therefore given family is self-ordered. self-orthogonal. Like this, we are saying that the given family is self-orthogonal. Here I am giving an exercise for you. Example, show that x squared by a squared plus lambda plus y squared by b squared plus lambda is equal to 1 is self-orthogonal. This is an exercise problem for you. How we will say that? How we will show that the family is self-orthogonal? Already we done this problem. How we done? First we eliminated arbitrary parameter. We will get a differential equation. Next we are replacing dv by dx as minus dx by dy. Then we will get another differential equation. If those two are same, then the given family is said to be self-orthogonal. And in this problem, where lambda is an arbitrary parameter, where lambda is an arbitrary parameter. So from this equation we have to eliminate lambda. After that, so first calculate lambda, next calculate a squared plus lambda, next calculate b squared plus lambda, next replace y dash as minus y dash, minus 1 by y. So if you done these three formulas, these four, you will get the family is self-orthogonal. So like this you have to complete that one. Now I am going through the next application of differential equations of first order and first degree, which is Newton's law of cooling. What is Newton's law of cooling? So in our nature, Newton's law of cooling is applicable to each and every way. Example, the refrigerator. What does the refrigerator do? What will do the refrigerator? As time increases, the temperature of the object in the refrigerator will be cooled. That is called law of cooling. And another example is, if you are boiling water, you are removing from the so boiling water, if you are removing from heat, then it will be reducing. As time increases, the temperature of the water will also be decreases. That is also one more example for Newton's law of cooling. So what is Newton's law of cooling? As time increases, the temperature of the object will be decreases. That is called Newton's law of cooling. Now here, see this. What is the definition of the Newton's law of cooling? Rate of change of temperature. For example, theta is the theta is the temperature of the object. So rate of change means this will vary with respect to the time. That is called d theta by dt. Rate of change of temperature of a body is direct proportional. Proportionality symbol is this one. Direct proportional to the difference between the temperature of the body. So difference, I want difference. Theta, difference between temperature and its surrounding medium. So if suppose every surrounding is having some temperature, that one taking as theta naught. So theta is the temperature of the object, theta naught is the surrounding temperature. So the difference of these two will be direct proportional to the rate of change of temperature. So that one I taken here, see this, that is d theta by dt is direct proportional to the theta minus theta naught. That implies here, if you are observing that, it is inverse proportion. Why? Because as time increases, this one will be decreases. So in that way, here I take a negative constant k. Negative constant k. So d theta by dt is equal minus k into theta minus theta naught. Here, use variable separable technique for evaluating the solution of this equation. That means bring this theta minus theta naught into the left hand side, this dt into the right hand side. Now apply integration on both sides. We will get integral 1 by theta minus theta naught dt d theta is equal minus k into integral 1 dt. Integration of 1 by theta minus theta naught is log of theta minus theta naught minus k into 1 integration kt. Here this one I got as logarithm. For our convenient purpose, constant also taken as logarithm. So this one is log c. Now bring this log c into the left hand side. Then this one log of theta minus theta naught minus log c is equal minus kt. It is in the form of log a minus log b. What is the formula of log a minus log b? Log a by b. Log a by b is equal minus kt. After this, bring this logarithm into this side. This log goes to the right hand side. That becomes as an exponential. So theta minus theta naught by c is equal to e power minus kt. Bring the c also the right hand side. C into e power minus kt. So that means theta is equal theta naught plus c into e power minus kt. This is called the formula for Newton's law of cooling. Theta is temperature of the object. Theta naught is surrounding media temperature. T is with respect to the time. At time t, temperature of the object is theta. So this is the formula for Newton's law of cooling, which is the temperature of the. By using this formula, we are evaluating the temperature of the body at any time t. And here, for our simplification purpose, here I am converting that formula also one more step forward. That one is theta 1. Let theta 1 is the initial temperature of the object. Initial temperature means at time t is equal to 0, the temperature of the object I taken as theta 1. So use that. That is at t is equal to 0, theta value is theta 1. Now use 1. 1 implies, what is 1? So this is our equation 1. So at time t is equal to 0, theta value is theta 1. So this is theta 1, this is 0. So apply that one here. See this. T value 0, theta value theta 1. So theta 1 is equal theta naught plus c into e power k into 0. E power minus k into 0. So this theta naught comes to the left hand side minus theta naught. E power 0 value 1. C into 1 c. So c value is theta 1 minus theta naught. Substitute this value in equation 1. So what I will get? Theta is equal theta naught plus theta 1 minus theta naught into e power minus k. Where theta is temperature of the body. Theta naught is surrounding temperature. Theta 1 is initial temperature. You have to remember these three. What is theta? Temperature of the body at time t. Theta naught is surrounding media temperature. Theta 1 is initial temperature.